In this tutorial section, we will look at the design of a monopole antenna at a resonating frequency of 2.5 GHz using HFSS. We will look at the monopole from theory before we start the design. This is how the monopole looks like. So the monopole is no different antenna. It's like a dipole antenna, half of a dipole antenna. So this is how it looks like. The length of the monopole should be lambda divided by 2. And as I said before, you would come across several materials teaching you how to calculate for the gap and the ground, the length of the ground. But the rule of thumb says that any accepted length that would not compromise with your design is okay. So after learning the diameters, the dimensions, everything, we'll go forward and design our monopole in HFSS. So I will name the project as usual KindMark, K for KindMark underscore dipole monopole underscore antenna. So after renaming our project, we will insert HFSS. Good. We would calculate for our important parameter, that is lambda. So we will start with lambda is speed of light divided by our frequency. So speed of light, that's lambda is C divided by F. Good. We know that our lambda is 0.12, that is 120 millimeters. We are good to go. We know that our monopole, the length of the monopole should be 0.125 lambda, or in short, it should be lambda divided by 4. So what we'll do is that we will go ahead and draw our cylinder. Name it monopole in the property window. Monopole. Change the material to PC. As usual, I will let it lie on the origin. The radius, I will choose a gap of 0.125 millimeters again, meaning that my radius should be half of what? 0.125, which should be 0.0625, and my height should be 1/4 times lambda. We had our lambda to be 1. That is 0.25. So 0.25 times 120. So we have our height to be 30 mm, But the thing is, from the diagram that we saw that the monopole is lifted a bit. So that will be the length of the gap. And I already said I would use 0.125. So I would elevate my structure 0.125 from the origin along Z. So I'll get 0.125. After everything, let me show you how it is. See that it is elevated, right? All right, so we can go ahead and draw our ground. So with the ground, we will choose a rectangle. Name it ground in the property window. Check the dimension. Want it to be at the origin. Before we do any adjustment. So the S size, say, I'll choose an S size of, let's say, 20 with Y size of 40. The thing is, I made them lie directly on the origin, so I have to change it so that it aligns like what we saw. Like what we saw in the diagram. Minus 20 divided by 2 minus 40 divided by 2. I think this should be okay. We have our ground now. What we do next is that we would introduce our put. Good. I will change to YZ, zoom, and introduce my put. So we choose a rectangle. It has changed from the usual sign. You see that it couldn't extend to the edge. It is not a problem. We can adjust it from this. So that is Y, and Y should be 0.125. That is twice of the radius. Good. So that everything is okay now. I would name it put. Give it a very beautiful color. Make it a bit transparent. And I'm done with this one. I can introduce my excitation
Audio Jungle.
lamp put. Defined with no error. I will check. Good. So I'll change my plane. Here's how it looks like. So I'll just assign perfect E to my ground. Assign boundary perfect E to the ground. So I'll check from boundaries that my ground is excited. So as well, I've assigned boundary to the ground and my excitation too. I'm now left with the airbox. So I said before, airbox will be fine, but any shape that makes you comfortable or easy to put around the whole thing, it's okay. I'll introduce the box.
Audio Jungle.
Name it airbox. Vacuum will be okay. Transparency, I want them for transparency to see what is inside and check the alignment. Because I chose the ground to be 20/40, it is best and nice I choose the same thing so that it will make the design nice and everything will fit inside perfectly. So 40. But for the Z, my whole monopole is 30. So when I choose a length of, let's say 70, will be okay. As usual, I want it to divide the coordinate into 2, so minus 20 divided by 2, minus 40 divided by 2, minus 70 divided by 2. Everything is perfectly aligned inside. Everything is well. So I will assign radiation to my airbox. That is assign boundary radiation to my airbox. I'm done. I have my perfect E to the ground inside. Radiation. And excitation. I have to zoom before I can see. Yes, that is highlighted over there. So I will now check what I'm left with. So I'm left with analysis setup as usual. Go to analysis, add solution setup, advanced. Now isolated frequency 2.5. Number of passes to be 10. Okay. Start that. Step 0.02.
Audio Jungle.
Preview my band to see if it is okay. Let's head here for the change from save my design, validate, everything is okay, and then write. So I'll go ahead and set up my password setup. And check
Audio Jungle.
everything is okay. But it's okay. So I'm waiting for the simulation to be ready. So when we plug our results, check the performance of Monopole antenna.
Audio Jungle.
The simulation is done. I believe we have no error. As usual, we have no error. So we can proceed and plot our return loss. Good. In this case, we can see that our resonating frequency is at 2.416, which is closer to 2.5. So with optimization, we can reach our goal. That is, this point would land on 2.5. So as usual, our standard will help us calculate the bandwidth. That is this point minus this point. I'll go ahead and plot the voltage standing wave ratio. We choose yes, WR. I want to plot with any unit. We'll change the unit. It's even okay. We have the 2 over here, that is our standard. So the bandwidth will be this point minus that. We'll go ahead and plot the H plane, that is far field report, radiation pattern, gain. Our plot for phi together with theta with a unit of or a function of dB. Remember, for E plane, theta is the principal angle. In the families, you will just plot 90 degrees of phi. So we are done. We can check our results.
Audio
The
Jungle.
monopole is also omnidirectional, so this is what we expect with unwanted radiations. Since the antenna is not perfect, you always get these radiations. Go ahead, plot the H plane to gain 5, gain theta, dB. I'll change the angle. It should be principal. Theta should be a family. You plot just a 90-degree. So you want the 90-degree cut of the 3D polar plot to see the radiation pattern of the E-plane. So I'm done. We plot in the report. So this is what we expect this time. Our unwanted radiations is a bit larger. I think Dr. Ellis will brief you on this. I've never seen it to be very large like this before, so Doc will brief you on this. So I'll go ahead and plot the 3D polar plot. So gain total with function dB, for gain 5 and gain theta with function dB. Any of them is fine. Good, as we had for there. As we have for the other ones, these are regions where the power distribution energy is low. This section, as I indicate with the pointer, is for the E-plane. It's for the E-plane, and those that go this direction is for the H-plane. This will be the end of our tutorial section. Thank you guys.